All right, we are back. We are doing 3.5. This is the last section that we're going to be doing for this chapter. I know that there is one more section in there. It's on graphing lines and stuff. We're actually going to keep a lot of the algebra review for the end of the year. That way we go over and remind you all the stuff right before you take Algebra 2. So let's go ahead and jump straight on into this. This is 3.5 and it is called the triangle angle sum theorem. Okay. So just as it looks like, we're trying to find the sum of the interior angles of a triangle. So the activity says using a straight edge and either a pair of scissors or carefully tearing a triangle out of a piece of paper. That sentence was funky. Now rip off all the angles of the triangle. Place them, man, I gotta work on this before I print it. Place them next to one another so that all the vertexes, are at the same point. What do you notice? What does this tell you about the sum of the interior angles of a triangle? Okay, now would have been an activity you guys would have done in class. If you want to do it right now, you're more than welcome to. You just need to make sure to have a perfect triangle. You could take a piece of paper, you could go over and go up and then down and then cut that out, and you would have a triangle. Now what we can do is we can cut out this one. We can cut out this one, so this one's going to have the frilly edge and then the sharp edges, and then cut out that one. If you set them all next to one another, what you will find is you'll have one angle. If you set it next to the next angle, which is a nice big obtuse angle, maybe it looks like this. And then we're going to set it next to this one right here. That'd be angle 1, 2, and 3. What do you notice about all of them together? They all come together to make a straight line. Okay, and a straight line is 180 degrees. So the triangle angle sum, theorem says, the sum of the interior angles, this is interior angles, of a triangle is 180 degrees. What that means is if you have two of the three angles of a triangle, you could figure out the third, or we can embed some algebra in there as well. Now, obviously, this is not a legit nice math proof, going over and making one triangle and cutting out the angles and sticking them together. That shows for this triangle, the sum of the interior angles is 180. We want to look at a mathematical proof that looks at infinitely many cases. Here is the proof. Now, to be able to do this proof, we need to know this little postulate here. The parallel line postulate just says there exists a line parallel to another line through a point. It's like common. It's just saying if you have a line and you have any point, doesn't matter where the point is, you could draw another line that was parallel to that line through that point. If it was another point, you could draw something that's parallel to that. And we just need it for this proof. So here is your legit mathematical proof of the triangle angle sum theorem. What they do here is they have a triangle and then they say here is the point right there. And here is the line we were talking about. We're going to go over and create a line that's parallel to it. Why in the world would we want parallel lines? Because when we know lines are parallel, we can use these things right here. So geometry toolbox again. This is the geometry toolbox. So anyways, what we are going to do here is follow through. It's a harder proof, so we are going to be doing fill in the blank. We're not coming up with the whole proof on our own. The first part says draw PR through B parallel to AC. That's just the parallel postulate. We just drew a line that's parallel to AC through B. Easy peasy. Angle PBC and angle 3 are supplementary. How do we know that PBC and angle 3 are supplementary? Well, linear pairs are supplementary. Linear pairs are sup. Remember, two angles come together to make a line, then they're a linear pair, and we know linear pairs are sup. Definition of supplementary angles. What must that say? I'm assuming it's going to say that the angle PBC plus the measure of angle 3 equals 180 degrees. Because whenever we were talking about the definition of supplementary, if you opened up a book and looked up the definition of supplementary, it would say two angles whose sum is 180 degrees. Next, how do we know that PBC is 1 and 2 together? Did we ever learn something that says a small angle plus a small angle equals the whole angle? Yes, that is the angle sum theorem. Or no, what do we call it? The segment, it's the angle addition postulate. Angle addition postulate. Okay, once again, this is a hard proof. I don't think I could write it all down on my own unless it was a fill in the blank. So we are just filling in the blanks. Therefore, how do we know that 1 plus 2 plus 3 equals 180? Looks like a linear pair, but pair means 2. This is 3. So it must have something to do with the stuff above. We know PBC plus 3 is 180, and now we erase the PBC and we put a 1 and 2. Substitution. Next, how do I know that angle 1 is congruent to A? How do I know this is congruent to this one over here? Those are parallel, and therefore these are congruent. What type of angles are those? Alternate interior angles theorem. How do I know 1 equals measure of angle A? And how do I know if they are congruent, then they are equal? Was there something in our geometry toolbox that said if they are congruent, then they're equal? Definition of congruence. And then lastly, what we do is we are substituting. So up here where I had a 1, I substituted in what 1 equals, which is A. Where I had a 3, I put in what 3 equals, which is a C. And therefore, I know that that angle plus that angle plus that angle equals 180. Which one was easier? Ripping off the corners? Which one was more easy to understand? Ripping off the corners of a triangle and sticking them together? Or this? I'm assuming ripping off the corner angles, but it is my job to make sure you guys see legit mathematical proofs. So once again, this was a hard proof. This was more of just filling in the blanks, trying to test ourselves out on our ability to fill in the blanks and give the reasons when we have statements and statements when we have reasons. All right, don't freak out if you didn't understand this proof. It was important for you to see, but I'm not going to ask you to reproduce it. All right, let's actually use the triangle angle sum theorem. Okay, if we are trying to figure out what this angle is right here, it's a triangle. We're looking at the interior angles. So we know that 110 plus 35 plus x equals 180. And if we were to solve this equation, we just have to subtract those away from that, and we'll find out what is left over. Let's go ahead and take your trusty calculator. 180 minus 35 minus 110. What'd you guys get? I got 35. Okay, what I want you guys to do is go ahead and try this problem. How are you going to solve for x on here using the triangle angle sum theorem? All right, hopefully you went over and added these up. 5x's plus 3x's plus x. I should really be showing all my work. 5x plus 3x plus x equals 180. That right there is 9x equals 180. So x equals 20. Okay. So triangle angle sum theorem just says the sum of the interior angles of a triangle equals 180 degrees. Now, sometimes you're going to get funky problems like this. And I know it's hard to read mine because it's got all these weird things on it. Basically, this is the weird thing. If you had this triangle right here, the sum of the interior angles of that whole triangle is going to be 180. But if you went over and had another triangle in here, the sum of this one is also going to be 180. And the sum of this one is also going to be 180 as well. You can also know that linear pairs equals 180. So we're going to run through this problem. We have one triangle, two triangle, and the whole entire triangle. And we're going to try to figure out what the missing variables are. Since this triangle right here has two of the three angles, we know we can do 180 minus this one, minus that one, and it will tell us what is left over for x. Calculator, we can say 180 minus 43 minus 59, and that is going to give us a 78. 78, x equals 78. Now, if I wanted to work with this triangle first, I couldn't because we have two things missing and they're different variables. But now I know that this is 68. What do we know about this linear pair right here? We know together they make 180 degrees because the lines are 180 degrees. So you would be able to do for y 180 minus 78, and that would tell you that you have 102 degrees left over. 102. Now, if that's 102, we could figure out z because we have 102, we have 49, and we need to know what's left over. So we could do 180 minus that equals that. 180 minus 102 minus 78, and that gives me, oh, sorry, 180 minus 102 minus 49, and that gives us 29 degrees. Now you got to be careful. Let's say you messed up on step one, just basic math mistake. Instead of 78, you got 68. Well, if this was 68, then you're going to get that one wrong, and now that you have that one wrong, you get the next one wrong. So you got to be very careful with this because the problems that you have snowball. The other thing you could have done is looked at the big triangle like that. This is 59. Together, these give us 52, 92. And then you could have solved for this one over here as well, and you should have still gotten 29. So many different ways to look at these problems. Just knowing that every triangle, the sum of the interior angles is going to give you 180 degrees. You guys go ahead and try out number 2. Try to figure out which triangle you want to work with first, and then go from there. All right, let's say I wanted to work with this triangle first. It'd be 180 minus 50 minus 84. Let's see what's left over for z. 180 minus 50 minus 84. That gives me 46. Next, if this is 46, I should be able to have these together be 180. So 180 minus 46 gives me y is going to be 134. And the reason it's going to be 134 is because these are a linear pair. 134. Next, we can work with this triangle. We can do 180 minus the 134 minus the 13. 180 minus 134 minus 13 equals 33 degrees. X equals 33. If I wanted to look at the big triangle to find out x first, this is 84. Together, those give you 63. We better get ourselves a 33 degrees in there. So 180 minus 63 minus 84 gives us 33. So you could have looked at this as a big triangle first and know that that big triangle is 180 degrees. Like I said, be careful. I'm not going to lie. I actually just worked this problem out incorrectly and I had to rewind the video. Why? I messed up on, which one did I mess up on? I messed up on the first part, the 46 degrees. I got like 64 or something like that, and then that messed up every other part. So just be very, very careful. Right, next one's, why don't we go over and I want to check this just to make sure that I'm doing it right. I'm going to do 180 just to make sure. 180 minus 92 minus 59, and we should end up with 29 degrees, and we did. Okay, so that one checks out. Let's take a look at this. The exterior angles of a triangle. The exterior angles of a triangle are going to be the non-linear angles when you extend the sides. Okay, so if you had a triangle and you extended the sides, each one will have a linear aspect over here, and then it'll have a non-linear aspect. That would be your exterior angle. If I continue this one out, you'll have the linear, the straight angle, and then you will have this over here, which is your remote angle. Go like this, you'll have the straight angle, and then you will have over here is going to be your exterior angle. How a remote interior angle works is it's on the interior and it's remote, far away. So rather than writing out a definition, I'll just show you. We had this triangle and I extended this out. Here's an exterior angle. This one and this one would be on the interior and far away. This one's right over here is too close. So that one and that one would be the remote interior angles. My triangle was like this. If that was my exterior, these are the two that would be far away and on the exterior. So if we take a look at this, we have a theorem. The theorem just says that your exterior angle, this, is equal to this one plus that one. So measure of angle 1, the measure of the exterior angle of a triangle, I'll write in words, is equal to the sum of the remote interior angles. It says interior. Is equal to the sum of the remote interior angles. Now, if I wanted to do this, this is basically how I would run this proof. I'll talk through it, but we're not going to do the actual proof. We know, once again, this is ugly. This is not a good proof, whatever. We know that 2 plus 3 plus 4 equals 180. The measure of 2 plus the measure of 3 plus the measure of 4 equals 180. We also know that 1 plus 4 equals 180. You guys agree with that? Okay. So what I could do here is now, since they both equal 180, we can set them equal to one another. 2 plus 3 plus 4 equals 1 plus 4. Why would I want to do that? Because I can subtract away a 4 from there, subtract away a 4 from there, and 1 equals the 2 and the 3 together. This is not a good proof. This is even correct notation. This is just a thought process explaining. All of these add to be 180. Those equal 180. Many times when we have two things equaling 180, we set them equal to one another. And the only reason I'd want to do that is so that I can subtract something from both sides and end up with what I want. Okay. Reason I didn't do the legit proof right there is because we have another page to run through, and we're getting a little bit far here time-wise with this lesson. So on this one right here, yes, you could go over for this problem and find out what that angle is by the triangle angle sum theorem, and then go over and know that these are a linear pair and find out what one is. But we are going to use the remote interior angles. Do you see how these two angles are on the inside of the triangle and they're far away from the exterior angle? That means these two should be able to add to get you 1. So this should be measure of angle 1 does equal 98 degrees. Two different ways to work this one as well. The way I'm going to do it is say x plus 59 is supposed to equal the exterior angle, 124. And I could subtract 59 and I could subtract 59. You end up with 1, 2, 4 minus 59, 65 degrees. So some problems, you will be able to do it in many different ways. What I want to do here is I'm going to give you a different problem. We are not going to work through this proof. What I want to do with you is give you this example. I want you to try to work through it. Say this one was 2x, this one was 5x plus 10, and this one over here is going to be 8x. Solve for x. Well, you guys should have looked at this and seen that this one and this one are remote interior angles, meaning they add together to get this one. So 2x plus 5x plus 10 must equal 8x. 7x plus 10 must equal 8x. Subtract 7x, subtract 7x, and you get x equals 10. That should have been your answer. Okie dokie. All right, so the main things that you guys need to know are that go back up, that the remote interior angles add to be the exterior angle, and that the triangle angle sum theorem says that the sum of the interior angles of a triangle are 180 degrees. All right, that's it. Just be careful, like I said, one last thing. Be careful on problems like, let me find it. Be careful on problems like these ones right here, because if you mess up on one of the angles, everything else is wrong, even if you have the right concept. So be careful, and you might want to double check those answers. Thanks so much for watching. Go ahead and do your homework. That was the last section that we're going to be doing, and you're going to have a test soon. Adios.